So let's continue now, class. So let's come back to topic. Okay, zeros full, we have covered this. Then there is your arrange, this we have covered. Now, class, there is one more function. Suppose let's say I'm writing np.arange. Let's say I'm writing 2, 20, let's say 3. So in this case, class, what will it will do? It will create an array from 2 till 20 with a step size of 3. The step size of 3. I know that I'm just showing you something. The step size of 3. But there is no another function np.linspace. Okay, linspace means linear space. Now if I mention 2, 20 here also, but 3. So what it will do? It will give, here 3 basically means 3 elements. Okay, it will divide the entire range of 2 till 20 into 3 equal parts. 3 equal parts. See, 11 minus 2 is 9. 20 minus 11 is 9. All of you got this, class, or not? In case of arange, we are able to control the step size. Basically, the space. Basically, I would say the difference between the elements here, between the consecutive elements. But in case of linspace, we don't control the difference. We control how many elements do we need in the entire range, and they will be equal spaced. All of you got till here or not? It will give float value, no? Because in order to divide that data, it will give float value. Okay, then there is, let's say, linspace. I'm writing same thing. 2, 20, 5. See, that is giving us 5 values between the range of 2 till 20, and they're equally spaced. 6.5 minus 2 is what? 4.5. 11 minus 6.5 is again 4.5. Again 4.5. Again 4.5. Got this, class, everyone till here? Indexing works, yes. See, list and your array is similar. Okay. Suppose let's class there is a to nahi, let's take A3 array. Okay, now this is 3-dimensional array now, class. Now suppose if I write here A3 of 0. Okay, so remember this is a sequence. First it will take the row, second it will take the column, third it will take the layer. Okay, and if no further dimensions are there, it will take them accordingly. Okay, now what happens? Suppose let's say A3 array is there. If I write here A3 of 0, it will give me this entire row. Sorry. First it will take layer, then it will take column, then it will take the row, and if there are other dimensions as well, then it will take them first. Okay, so here you can see when I write A30, it is taking the entire layer first. First layer, it is taking that. Then if I write here class A3 0, so from first layer, it is taking the first row. Okay. Then if I write here class A3 0, then it will give us 1. All right, Vishal. Actually, I was getting confused because of A2. Okay, suppose A2 is there. So now here it will take first row and then column. Clear, class, everyone? All of you got this till here or not? Okay. Now next thing, class, that is here is your reshape method, linspace. Okay. Suppose, class, let's say I was saying np.a linspace. Right here, let's say 1, 9, 2. 2 method, it will give a 1 and 9 only. Okay. What happens, class? Linspace basically returns equally spaced, not necessarily integers, numbers in a given count of numbers is controlled. Suppose I'm writing here np.linspace 3, 45, 10. So in the range of C, the range of this, it is giving us 10 elements equally spaced. Can there be more than one decimal for this case? What do you mean by one decimal? After decimal point. It can be there. Okay. Also, one more thing that we can do, I guess, should be round function should work in no. Doesn't define round method. Okay. So we'll have to change them. So clear class till here? Then space. Okay. This we have covered. Now let's suppose class. How will you divide them equally then, Jagdish? If I ask you to divide the range of 1 to 5 in two parts, or 5 in two parts, so you get 2.5, no? Because 5 cannot be equally divided, right? Similarly, if some range you cannot divide a range equally, then obviously it will give a float for completely it is dividing, yes. I showed you 3, 20, 3. Here it is able to divide them, so it is giving us whole number. Okay. Now suppose class, let's say A3 is there. Okay. Now what I can do, I can write here A3 3 is equal to A3 dot reshape. Okay. Now class, there is a condition whenever we are reshaping now something, there is a condition for reshaping. Read this. We can reshape. We can use reshape method to reshape an array. Okay, but there is a condition. An array can only be reshaped, okay, when the size of the array before reshaping and after reshaping remains same. Can anyone tell me the reason why the size needs to be same before reshaping and after reshaping? Reshaping means suppose if there is an array of 2 by 3, I can reshape it to 3 by 2. जैसे portrait को landscape में कर दिया like that. Can anyone tell me, class? Because we are not changing the values exactly. Okay, basically, what happens? I will explain that also. What happens? Reshaping with size remains same. That means what? Tell me. Size basically means what? Number of elements, right? The number of elements before reshaping and after reshaping should say remain same. Let's say if it is not same, then what will happen? It will lose some data, or it will add new data. Okay? Both of them are not possible, right? Because obviously losing data is possible, but the problem is that which data to lose. Okay. Plus, if it is adding data, so adding data from where? Right? So in case of reshaping, your size should remain same. It is not talking about the shape. Shape can change. Suppose let's say A3 is there. So what is the shape of A3 currently, class? A3 dot shape. It is 2 by 2 by 4. Now, and what is the size of this? 16, right? So now I can reshape it into 4 by 4. See, 3-dimensional array I am reshaping to 2-dimensional array. See, same data, same manner. I can reshape it to maybe one dimensional or also, or maybe in 3 dimensional, 2 by 4 by 2. See, got this class, everyone? I can reshape it to one dimensional also. 16 by 1. 16 by 1 essentially is a 2-dimensional array. Okay, having 16 rows and 1 column. But if I remove 1, then it becomes 1-dimensional array having 16 columns only. Only 16 columns. There is no concept of row here. Clear class so far? Okay. Suppose that let's A2 array. Right here class A2 dot shape. It is what 2 by 4. I can now write A2 dot reshape. See, it is not reshaping A2. It is creating a different array. You can store it in a variable if you want to. A2 dot reshape. I will reshape it to maybe 4 by 2. See. Suppose let's say I want 3 dimensional. I am doing some processing, and for that I need 3-dimensional array. So 4 by 2 by 1. See? Or let's say 1 by 4 by 2. So I'm getting 3-dimensional array now. Notice one thing, class. Here there are 2 brackets. Here there are 3 brackets. There is a single layer only, but the concept of layer is there. Okay. But here in this case, there is no concept of layer, only 2 dimensions, rows and columns. That's it. What is factoring time? The reshape factoring time, fetching time. Fetching time will remain same, no? It will remain same. That is a matter of nanoseconds only, so that we don't consider. Clear class to clear? Reshape 3D, no? So I reshape 3D here, Rohit. See, A3 is a 3D array, 2 by 2 by 4. Okay, so we can reshape that to 4 by 4. See, reshape 3D to 2D. Fetching values will come different. Yes, Javardhan. In that, yes. So during fetching, the values will come different. Yes, that will be there. Got this, Rohit class? Rohit got this? You can reshape. See, this was 2 by 2 by 4. I reshaped that to 2 by 4 by 2. That also you can do. Obviously, numpy is completely different plus completely new. We use reshape when we want to change the data from one dimension to another. Suppose let's say I have a two-day matrix in which there are subjects and students. Okay, rows and columns, students and subjects. Okay. Now, what I want in place of subjects, I want students. In place of students, I want subjects. So that I can do. Okay, just say if you remember class, let's say this is A2 is there. Okay, if you write here A2 dot T. Anyone any idea what T represents? It is a 2D matrix. So what it might be? Transpose, right? Transpose, all of you remember? Rows becomes columns, columns becomes rows. See? Similarly, you can transpose a 3-dimensional matrix also. This was your A3. See? Transpose version. Your इसमें क्या हुआ? Your rows are rows only. Your columns. The columns become layer. See, in case of reshape, now what will happen? See, if I do reshape of A3 only, I will reshape to, let's say this is A3 dot T, na? Just a minute. A3 dot T dot shape. 4 by 2 by 2. 4 by 2 by. See the difference in the output class. Reshaping. Reshaping, what it does, it will take the same data. Okay, it will not change the rows to columns and columns to rows. No, reshape is not changing the rows to columns and columns to rows. It is just rearranging the data in another shape, in another like following the same sequence. Okay, but it is just rearranging the data to change the shape. Okay, but in case of transpose, it is like changing rows to columns or layers to columns and so on. Okay. Clear here? Let's continue class now. Okay. Now there is one more thing class, flattening the array. Suppose let's say A2 is there. Flattening the array basically means converting into single dimensional. Layers will convert to columns. Huh? Yes. If it is a 3D matrix, yes. Sure. If it is a 2D matrix, then rows will become columns will become rows. Basically, last in case of transpose, now what happens? As far as I remember, the AND values. Okay, suppose let's say 3D matrix the layer is there, then row, then column. Okay, so the last two, leftmost is row or layer, rightmost is column, right? So that will get interchanged. Okay, now let's continue class. Converting into single column. So let's say A2 is there. So if I write here A2 dot flatten, so you can see it will convert everything to one dimensional. Case of flatten. So see here we just dealing with data, and you're just converting the data into one form to another, just so as to like make the processing or whatever you're doing any operation easier. Okay. Now class, let's continue. Let's say, suppose let's say this A2 is there. Okay, let's say this A2 is there. Okay. Now, suppose I say A2, A21 is equal to A2 plus 1. So see what will happen in this case now. This is called as element-wise operations. Not element-wise. Binary operations, because it will implement now each and every of the element of the array. So you can see A2 plus 1. So it is adding 1 to each and every element individually. Okay. So suppose class, let's say you have a list with you. Let me show you. Suppose let's say you have a list with you. Okay. And you write L plus 1. So what will be the output class? What will be the output class? It will give us error, right? Okay, because we cannot convert a list. Okay, we cannot add a list with an integer. Okay, there are different types. We cannot add them together into a single one. But suppose class, let's say if I write here np.array of list plus 1, then it will work fine. So suppose if you now what you can do, suppose you want to add some data, some let's say 1 or whatever you want to do some arithmetic operation to each and every element of the array. So every element of the list, so convert it into array, add 1, and then typecast it back to a list. All of you, Yes. Got this class, everyone? Got this class, everyone, or not? Suppose you want to do any kind of operation on every element of the arithmetic operation on every element of a list. So you cannot do that directly, but you can do this in this manner. No? To list is basically used to convert the array. See, O is basically what? Print O. So you can see O is an array. Okay. So if you want to convert the array to a list, so there is a function called as toList. Converts array to a list. Similarly, you can do any kind of operation. Let's say A2 is there, or let's say A3 is there. You can write A3 into 5. So you can see all the elements got multiplied by 5 individually. Okay, so all the arithmetic operation, all 7 arithmetic operations that we saw: addition, multiplication, subtraction, division, then your floor operation, power operation, and modulus. All 7 of them can be clear till here or not? Last, at least respond no. Next is array indexing. Okay. Now what happens, guys? Array indexing, na? Like normally, suppose let's say you have a list with you. So write here L0, you'll get 1, 2, 3, 4, right? Simple indexing is there. Same type of indexing is present in array also. Okay. A is equal to np.array of L. The same type of indexing is present here also. If I write A0, so it will give you the same output, but in terms of array. Okay. Now there are 2 more indexing present in this. Okay, called as integer array indexing. Okay, I will cover one more is there, Boolean array indexing. I will cover both of them. First, let's see. Let's see this A2 is there. Okay. Now, suppose class, let's say I want to fetch these 2 elements. So what I will do, I will write here A2. I will pass to list here. Okay. Tell me what is the what are the coordinates of 2 in terms of rows and columns? 0, 1, right? Row 0, column 1 for 2, and for 3 it is 0, 2. Okay. So what I will do, class, I will first give it 0 here, and I give 1 here. 0, 1, then I will give 0 here, and I will give 2 here, and I will get 2 and 3. Got this, class, or not? It is like this. First we have to give row coordinates, and then we have to give column coordinates. Let me show you another example. but I am giving more example. Suppose class, let's say I'm creating array D is equal to np.array. Let's suppose we have this array with us. Okay. Now, this one is the row. This is your row. And this one is column. I hope class you already know this, no? Row and column, do you know? Row is horizontal and column is vertical. Okay. Now, indexing starts from 0. Okay. That means 0 row, row 0, row 1, row 2, 0 column, 1 column, 2 column, 3 column. Now if I write it plus D, suppose class, let's say I need this 5 and I need this, I don't know, 7. So what are the coordinates of 5? 1, comma 0. What are the coordinates of 7? 1, comma 2. Right. So what I will do, I will give two lists here. First list and second list. Because it is a two-dimensional array, I will that is why I'm giving two lists. First list will take the rows only, row coordinates. 1. And second will give us 0 column. 1, comma 0 है ना? For 5. So it is, you can see it is giving us 5. Now, suppose I need 7 also. So I will give 1 and here 2. So it will give us both of them. Clear class, everyone or not? Clear class still here? Okay. Now, similar manner, you can do slicing also here. So before slicing, you have to cover indexing first. Okay, this is called as integer array indexing. Now there is one more called as Boolean array indexing. And Boolean array indexing class is basically dependent on the some Boolean condition. How you can get data from multiple rows and columns. Say, suppose let's say you want this 9 also. So this 74. 74 is what? 2, comma 1, right? 2, comma 1. So you write 2 here and 1 here. You can see. If there is a layer also, suppose class, let's say you want, write down 0, 1, 0, 1, 2, 3. This is also 0, 1. And this is 0 layer. This is 1 layer. Okay. Now suppose class I want this 6. I want this 13. So 6. What are the coordinates of 6 class? Layer 0. Row 1. Column 1. Coordinates of 13. 1. 0. 2. Okay. So what I can do? I can write here class A3. Now since there are 3 dimensions, I have to give 3 lists separately. first for layer, second for row, third for column. ये क्या हो जाएगा 0 1 1. See, I'm getting 6. I need 13 also. So 1 0 2. Clear class till here? If there is single dimensional, then single list. 4 dimensions, 4 list, and so on. So next class, there is your Boolean array indexing. What happens in case of Boolean indexing? It takes a condition and returns data for which condition holds true. Okay. Just for understanding, you can understand it is like it is kind of filter function. First thing, also it is majorly used for filtering. Okay, let me explain. Suppose class, let's say A2 is there. Now you write a condition kya? A2 modulus 2 equal to 0. So you can see it will return all the elements from the array which are following this condition. Clear class? Let us see another condition. A2, let's say I'm saying A2 more than 6. So it will give us all the elements which are following this particular condition. Result will always be a single row. Yes. Try to understand this. Now, how will it get to know that which dimension do you need? How many dimensions you want? What shape you want? You cannot calculate from its own end. No? You can reshape it later on if you want to, but by default it will give you single one-dimensional array. Yes, row will be single. Okay. With integer indexing, we can fetch only 2 values. With integer indexing, we can fetch only 2 values. What do you mean by that? We can see we fetch 3 values here. Any number of values you can fetch, no? Let's continue class now. Next is your slicing. So suppose let's say let me show you the A2, then I will show you the A3. Suppose class, let's say I want to slice out this data, okay, separately. So what I will do, first class, since it is two-dimensional array, first we'll do row slicing and then column slicing. Can anyone tell me which like 1 second, just give me a minute. Okay. Now class, can anyone tell me that which rows do we need in the output? 1 and 2. So if I want to mention 1 and 2, can I mention 1 colon 3 or maybe 1 colon only? Same thing, no? Because there is no one starting from one index till the end, right? This is for row. And which columns do we need? 1 and 2. So 1 colon 3. See? Now suppose class, let's say I want this let's say. That should be what? Which rows do I need? I need all 3 rows, right? So I will just put colon. Which columns do I need? 1 colon 3. When you write 1 colon 3, when you write 1 colon 3, that means what? 1 and 2, na? That means 1 and 2 and or not? N minus 1 tak jata hai na? But if you do you remember, it goes to n minus 1. Whatever number you mention, it goes to n minus 1. See, we are getting this 3, this data. Now, suppose class, let's say what will be the output of this? $719. Now suppose I want this. So मेरे को कौन से rows से? I need 1 and 2 rows, row number 1 and row number 2. I need row number 1 and row number 2. I need 0 column and I need 1 column. First, I need to mention row slice. Okay. Which rows do I need, class? 1 and 2. So I can write 1 comma 1 and 2 as 1 column also, or maybe 1 column 3 also. Same thing, right? Clear, class, or not? And which columns do I need? 0 and 1. So 0 and 1 can be written as 0 colon 3. See? ये क्या हुआ? अच्छा 0 colon 2, sorry. Got this class? Or this can also be written as D 1 colon 2. Understood everyone till here or not? See, when we are Raj, when we are starting from the starting node, okay, when we are starting, जैसे यहाँ पे 0 से start हो रहा है, right? So even if I don't mention 0, that also is fine. 0 colon 2 can also be written as colon 2 only. Similarly, 1 colon 3 का मतलब क्या हुआ? 3 is the last index, no? There is no row. How many rows are there? 0, 1, 2. There is no row after 2. Even if I mention 1 colon, that then also it will go till the end. There is nothing after the colon, it will go till the end. If there is nothing after before the colon, it will start from the beginning. Where, Gaurav? For row you are seeing or column? Which rows do we need? We need row number 1 and we need row number 2 now. So for one row 1 and 2, we need to write 1 colon 3. मैंने क्या बोला? That whenever you mention some number, it will go from 1 till n minus 1. Whatever number you will mention, it will go 1 before that. If you mention 4, it will go till 3. If you mention 5, it will go till 4.
Hi, sir.
Yes, Gaurav.
Yeah, actually, the row is 0, 1, 2, correct?
Correct.
So we need row number 1 and 2, right?
Right.
So, the row number 1 is 0, row number 1 is 5, and row number 2 is 12.
Right.
So how we should mention 1 colon 3? Because the fourth row is not available.
Fourth row is not available, but when you mention 3 na, so it will go till 2 only. See what happens when you write m colon n. So it will start from n and it will go till n minus 1. जो भी number लिखोगे उससे पहले तक जाएगा वो. So when you mention 2, when you mention 3 here, it will take 1 and 2 only. Suppose let's say if you mention 1 colon 5. So in that case, it will take 1, 2, 3 and 4. This number is not included in the output.
Yeah, means in case of indexing, it will go for means n minus 1, 0 to n minus 1.
So this is also indexing, no? Yes, Jagdish.
Yeah, got it, sir. Thank you.
See, the simple thing class try to understand is that nobody, like, they are not going to change the base concepts. Na core concepts that are already there in Python are going to remain same always. how can we create an array of 2 rows, 3 columns? While linspace will give you a single dimension array. You have to reshape it. And when you said 2 rows, 3 columns, that means 6 elements are there. Simply write here p is equal to np.linspace and 2 rows and 3 columns. Na? So 1, 100, 6. Basically 2 rows, 3 columns. Okay, so you will get the linspace. Okay, and then reshape it to 2 by 3. See, got that? Because I hope all of you understood everything till here. Let's continue. Okay. So in an interview, they asked you this question. Okay. Just a minute, class. np.linspace start, stop, number, endpoint. You cannot control the shape here. You have to reshape only then. How about linspace random will give you random integers? The difference will be it will not equally spaced नहीं होंगे ना. It will give you random integers in that case. So the elements won't be equally spaced. In case of linspace, the only benefit is that it is equally spaced. Okay. Now suppose class, let's say I want these 4 elements of the array. So what will I write? Which rows do I need? 0 and 1. For mentioning 0 and 1, can I write column 2? Right. Then which columns do I need? I need 0, 1, 2 and 3. So can I write 2 column? See, all of you understood this or not? Let's continue now. Shashank, whatever, like it is just 15 minutes left. Okay, so whatever I'm going to cover, that is literally like it is easier than this. Whatever I'm going to cover next. I will share one assignment of NumPy. I think I have some assignment already there, so I will share it. If not, I will make one and share in a day or two. Now, class, there are some operations that you can do. Suppose, class, let's say you have array this. Now there is another array. ये रहने देते हैं. Creating another array. 2 is equal to np.array 5, 9, 0, 1. Comma 1, comma 8. So these 2 arrays are there. Now since the shape of both the arrays is same, what I can do, I can write here AQ is equal to A plus Q. Okay, so you can see this is basically called as element wise arithmetic operation. Okay, element wise arithmetic operation. Basically, you can see it is adding element wise. 5 is getting added to 1, hence 6. 9 is getting added to 2, hence 11, and so on. All of you got this? All of you got till here or not? Okay, so similarly, all the 7 arithmetic operations you can perform in this manner. Okay, no problem at all. I already told you, suppose if I want to add 1, if I simply write 1, so it will add 1 to every value. But if I give a array of the same shape, then it will add them like this, add them element wise. Okay, now suppose class, let's say I am writing A into Q. So this is the case. Tell me, is this matrix multiplication? Does matrix multiplication happen in same manner? No, no. Matrix multiplication class, if you remember, in that what happens? The rows of the first array get multiplied by columns of the second array, right? Okay. Plus, there is one condition that suppose if there is an array m cross n, there is an array p cross q. Okay. So in that case, p should be equal to n. Only then you can do multiplication. Number of columns in the first array should be equal to number of rows in the second array, right? All of you remember this? So by that logic, if A is there and Q is there, can I do matrix multiplication between them? Can I do matrix multiplication? No. Are the number of rows in the or the number of columns in the first array equal to number of rows in the second array? This is 2 by 4. This is 2 by 4. Okay. But what I can do, I can write here Qt is equal to just a minute, class. We have transposed it. Now we can multiply them. Okay. A dot 2t. So you can see we're getting a resultant matrix of 2 by 2. Okay. And basically that is your matrix multiplication. We cannot multiply normally, like normal matrix, this element wise multiplication you cannot do between A and Qt. Clear class so far? Clear class so far? Okay, let's continue now. Suppose class, let's say we have this array D. Okay, now try to understand. If I write here D dot sum, simply D dot sum, what it will do, it will add all the elements of the array. As simple as that. But if I write here class D dot sum, how many dimensions are there here? How many dimensions are there? 2. So can you tell me which x's are present here? Which x's are present here? X and y, or in terms of numpy, we call them as x is 0 and x is 1. X is 0 and x is 1. If you remember, I showed you also in the starting. See, x is 0, x is 1, x is 0, 1, 2, right? There, class. Can you see these axes? Now what I can do, what I will do now, I will write here axis equal to 0. So here you can see, class, what it will do. It will add the data with respect to row. Basically, the data of the rows will be added together. That means first element of the first row, first element of the second row, first element of the third row got added together to give us 18. Okay. Second element of the first row, second element of the second row, second element of the third row. All of you getting this or not? Suppose class, let's say if I say that these are the students, okay, and these are the subjects. The row is representing student, a single student, and this is maths. Maths. This is physics. This is chemistry. This is English. Student 1, student 2, student 3. Okay. So if I want to see the sum of marks of all the student in mathematics, so I can do this now. Got this, class? Got this or not? And if you want, let's say there is mean also. See, so this is the mean marks of students in the mathematics subject. Are you able to understand the logic behind it or not? Mean marks of students in the mathematics subject. Right? Similarly, you can write class d dot sum x is equal to 1. So this is the mean marks student wise. See. Mean marks, average marks of the first student, average marks of the second student, average marks of the third student. All of you got clear till here? एक्सिस 3 नहीं एक्सिस 2 0 है ना 0 स्टार्ट हो रहा है ना 0 1 so axis 2 will be layer Similarly, class sum is there. We can try min, d dot min. Axis you can mention in that also. D dot max is also there. Sum I have shown min, max, mean average value I have shown. There is d dot okay, min, max, sum. Prod also I guess is there. There should be prod also. Okay. It is giving a very large number. Product we usually don't do. Then there is your min, max, sum, mean. Amar, we are taking a two-dimensional matrix. Now, two-dimensional matrix mein how many x's are there? Only 0 and 1 is there, na? That is why it will work 0 and 1 only. If it is a three-dimensional matrix, then you can use x is equal to 2 also. In four-dimensional matrix, you can use x is equal to 3 also. X is equal to 0 means row. X is equal to 1 means column. ऐसे होता है. Let me show you class what happens ना. Suppose let's say you write d dot shape. d dot shape. ठीक है. So इसमें क्या है? This is column. This is row. This will be axis 0. This will be axis 1. And this is column. This is row. This is layer. This will be 0, 1. Understood? It is not that axis 0 will be row always. It depends on the shape. Now, class, do you know what is the meaning of cumulative sum? Yes, right. Do you know what is cumulative sum? No, cumulative sum means like, wait, let me show you. I cannot explain as such. Cumulative sum की definition क्या है? Running total. See, a cumulative sum is also known as running total. As a sequence of partial sums of given data set or sequence. Sum of the current and the next row frequency, right? Okay. So let us see this class. So just to explain this, I'm just explaining this first with a single dimension array. See this class. First, we're getting 1 as it is, right? Then 3 is basically the sum of 1 and 2, right? 6 is the sum of 1, 2, and 3. 10 is the sum of 1, 2, 3, and 4. Getting this class? Or in other words, this is not Fibonacci, no, Abhishek. Okay. In other words, we can also say 1 as it is coming. Then 3 is the sum of 1 and 2. Okay. Then 6 is basically the sum of 3 and 3. Current input and the previous output. Current input is 4, previous output is 6. All of you got till here or not? That is your cumulative sum. Similarly, you can do exercise also, x is equal to 0, x is equal to 1 also if you want to. Similarly, there is a cum prod also, cumulative product of A1. Clear everyone till here? Any doubt? It will multiply, no, Amar? In cumulative sum, it is adding cumulative product, it will multiply. Let's say if you see 1, 2, 3, 4 is there, right? 1 as it is आ गया. Then 2 is basically coming from 2 multiplied by 1. Then 6 is coming from 3 multiplied by 2. 24 is coming from 4 multiplied by 6. Current input and the previous output. Current input and the previous output. Understood this class or not?